Hello, we're Yeongjun Hong and Hyunil Jang to present about team versus individual play in finitely repeated Prisoner's Dilemma games by John Cagill and Peter McGee from the American Economics Journal. We'll assume that everyone here is aware of what Prisoner's Dilemma game is, since we have covered those materials in lectures. Let's first talk about motivations of this experiment. Authors suggest two motivations for running such experiment. One is to compare economic decisions between teams and individuals, and the other is to understand typical patterns for Prisoner's Dilemma games. Thus, the experiment is run by dividing into team v team and individual v individual games and investigating the results. Following motivations, what question does this paper raise to us? Would there be any difference between typical Prisoner's Dilemma game within individuals and Prisoner's Dilemma game within teams? Comparing teams and individuals' game patterns, which side would be more cooperative? Answers to these questions will be presented on the following slides. Alright, let's begin the Prisoner's Dilemma game. First, we're going to have 5 sessions composed of 7 stage games for both individuals and teams. So, each session consists of 7 stage games, whereas one stage game is a term used for one Prisoner's Dilemma game. In Team v Team games, team consists of yourself and a partner, where a partner will be randomly assigned. After each session, you will be rearranged with new randomly selected partner. Previous partner will be excluded from rematching. Arrangement for teams will be announced, so you will know who you're playing against. Other fundamentals follow the standard version of Prisoner's Dilemma game. For each stage game, your team can either choose to cooperate or to defect. While making decision, only discussion within team is allowed. Discussion between teams is restricted. Payoffs for each stage game is shown on this table. All games are played simultaneously, and upon agreement within team, all teams must make decisions in a given time limit. Results will be announced publicly, so everyone can know if their opponent has cooperated or defected. In calculation of payoff for Team v Team games, each member of a team will receive his or her team's payoffs. For both individual and team games, person with the highest cumulative payoffs wins the game. What do you think the ideal strategy for this game is? The authors have reported results of this game in 2 parts. First, comparing patterns of play between individuals and teams. And second, understanding team behaviors through analyzing team dialogues. First, we will see results for comparing teams and individuals' pattern. The graph is provided for a brief view of results. X-axis represents stage games, and Y-axis represents proportion of teams on a cooperative path. Here, first session is the focus point, because other sessions are largely dependent on experiences from previous sessions. This table shows the results of each stage game in the first session. At first stage game, teams are much more defective than individuals, but teams become increasingly cooperative as the game goes on. What is the possible reasoning behind this pattern? Explanation provided by authors is the discontinuity effect. Discontinuity effect states that the competitiveness among teams are greater than the competitiveness among individuals. Thus, teams will follow more rational choice than individuals, which is to defect. However, as they receive their payoffs, they will recognize that the Nash equilibrium is not their expected payoffs, which will result in increasing cooperation among teams after the first stage game. In the final stage game, however, Teams do not have to maintain cooperative relationship with their opponent, since teams would be rearranged after this game. However, there are still some cooperation shown in the last stage game for both teams and individuals. Why is this? Possible explanations include evidence of altruism and results of mistakes, confusion, and naivete among participants. Another pattern shown is that significantly less cooperation is shown for teams than individuals in the last few sessions. There are two explanations for this pattern. First is that teams unravel faster than individuals. Both teams and individuals would try to unravel a bit faster than their opponent to make more profit than them. And according to the discontinuity effect, that period of defection for teams would be faster than individuals since teams are more competitive than individuals, which means that teams will have much more experience with defection than individuals. Thus, by last few sessions, teams will realize that defection in last few sessions is dominant strategy, since their opponents will also have same thoughts, which is to defect. Also, teams can think more rationally through team discussions. They will know better than individuals that maintaining cooperative relationship in first few sessions and defecting in last few sessions is dominant strategy for this game. However, in defection patterns, there are minimal differences between teams and individuals. Although teams defect earlier than individuals, when we compare defection patterns within teams and within individuals separately, there are some similarities shown. For both teams and individuals, when they get defected, the common response is to defect in intended period and to not change any plans. Usually, if the opponent cooperates, the common response is to change plans of intended defection and maintain cooperation longer. However, if one starts to defect, individuals and teams both respond by defecting as they plan to. And now, let's look at the results for analysis on team behaviors through team dialogues. This slide shows how authors have categorized team dialogues based on team decisions to cooperate or to defect with some additional categories. For example, category D2 is a combination of dialogues that has a pattern of they have defected first, so we also will. So what do you think? Which type of dialogue would be most dominant in teams who have cooperated? What about teams who have defected? For teams on a defective path, 91.7% of them showed a dialogue pattern of D1, which states that defection is the safest choice. And it is partially correct. Defection is dominant strategy in Prisoner's Dilemma game. Among teams on a cooperative path, 70.6% of them showed a dialogue pattern of C1, which views the game in utilitarian perspective that if we cooperate, they also will. Here, the keyword is not rationality, but rather ideal and sociality. So looking at team dialogues, there are some visible patterns present. First, cost of signaling cooperation, that is, to choose cooperation in the first stage game or before your opponent, was relatively low by the second session. By the second session, 2/3 of teams showed C2 or D5 dialogue patterns, and this rises to 86.2% by the fourth session. C2 pattern shows that teams choose to cooperate in the fear of not responding to their signal of cooperation. But when we have majority of teams having this same pattern, it indicates that many teams will choose to cooperate in future sessions without one side having to sacrifice to signal cooperation. D5 pattern shows that teams who are too late to cooperate in the current session decides to cooperate in next session. Same for this pattern. When we have majority of teams having D5 pattern, teams will not have to signal cooperation in the next session, since majority of teams will decide to cooperate. Second, teams' decisions are heavily influenced by trial and error. In early sessions, the stable reward of 105 obtained from cooperation results in teams' consistent cooperation, which increases the average profit overall. Then, as teams enter later sessions, teams begin to defect a round earlier than the previous session to earn a higher reward of 175 and give their opponent a very low reward of 5. And teams with experience of defection will very likely to defect in the next session to make up for their loss. Lastly, the common pattern is to defect in the first stage game and then to cooperate. This can be linked with the first point we have covered, which deals with the cost of signaling cooperation. Since teams have more rational thoughts due to team discussions, there are more fear of sucker payoff when they choose to cooperate. Thus, teams will choose defection, which is the safest choice, in the first stage game and see if their opponent will cooperate or defect. So, what was the question we raised in the beginning? It was, which side is more cooperative, teams or individuals? This can be confirmed through results we have presented until now. We were able to understand that teams are more rational through result 1, and through result 2, we were able to look at dialogues of those teams with rationality. Teams are more rational than individuals because human nature is to interact with others through dialogue and develop better ideas. This can be seen from a sociological perspective rather than an economics perspective. This is why teams seek for dominant strategy, which is to cooperate in early sessions and to defect earlier than opponents in later sessions, resulting in lower cooperation rate for teams than individuals overall. Alright, this concludes our presentation on team versus individual play in finitely repeated Prisoner's Dilemma games. If you have any questions further, please feel free to ask. Thank you.